So we're looking at exercise 7B. This is the quotient rule. Now there's a couple of different ways we can do this question. So first of all, we can start by squaring each term inside here in parentheses. So in other words, x squared over sine squared x, which I'm going to write like this because we're going to do the chain rule in a second. So as this is a quotient rule question, our top term is u, and the derivative of that is just 2x. Our bottom term is v. Now, normally when we think of terms on the bottom here, we'd say this is an exponent of -2. We're really just looking what is the bottom term here. So when we're doing this, v just equals sine squared x. Now, the reason I wrote it like that is, so when I do the chain rule now, I'm going to bring the power to the front, which is 2. I'm going to leave this alone. Decrease the power by 1, which would just be to the power of 1, so I'm not going to do anything for that. But also times by the derivative of what's inside the parentheses. So the derivative of sine x is cosine x. Now, some of you might actually recognize this as an identity. This is actually sine 2x, but we're going to leave that for this question. Now, when we do the quotient rule, we're going to do v du minus u dv all over v squared. So when we substitute in there, v is sine squared x, times by du, which is 2x, so I'm actually going to bring that to the front using the commutative rule, minus u dv, so x squared times by 2 sine x, so I'm going to write that as 2x squared sine x cosine x, all divided by v squared, which is sine squared x squared squared. So we've got to make sure that we don't miss squaring what v actually is. Now looking up here, I can see there's some common factors as well. I can see there's 2x. I can also see we have a sine x and a sine squared x. So I can take sine x as a common factor here. And then what I get left with is 2x is already taken care of. Sine x times sine x is sine squared x. Now 2x, but this is x squared, so I actually need an x. Sine x is already taken care of, but I am missing the cosine x here. All divided by sine squared x squared. So power to a power rule, we're going to multiply here. So we've got sine x to the power of 4. And we can do one more bit of simplifying here at this stage as well. As I got sine x and I got sine x to the 4, when I divide, I'm going to subtract the exponents here. So 1 take away 4 would actually give me 3 on the bottom. So that's one more little bit of simplifying I can do for this question. So 2x times by sine x minus x cosine x, all divided by sine cubed x. Now the other way I can do this question is to do a chain rule. So what I can say is I can bring the power to the front, leave this alone, decrease the power by 1, but also times by the derivative of what's inside the parentheses. Now what's inside the parentheses is actually a quotient rule question. So our top term is sine x, and the derivative of that is cosine x. Our bottom term we call v, and the derivative of v is 1. So when we work out the quotient rule, we're going to do v du, so x cosine x, minus u dv, so sine x times 1 is just sine x, all over v squared, which is, in this case, is x squared. So when I was doing the chain rule up here, I brought the power to the front, decreased the power by 1, but then I have to times by the derivative of what's inside the parentheses, which would be this. So x cosine x minus sine x, all divided by x squared. And when I combine terms here, I can see that I've got x and I've got x squared on the bottom, so I could just go ahead and make a common denominator there of x cubed. So it would be 2 sine x times by this, all divided by x cubed, which does actually agree with the previous answer. So just a different way of thinking about that